Welcome viewers. In this video we will see the details about short circuit admittance parameter Y parameter coming under two-port network. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic two-port network. Under that short circuit admittance parameter Y parameters. The Y parameter of a two-port network for the positive direction of voltages and current may be defined by expressing the port current I1 and I2 in terms of voltages V1 and V2. So the two-port network, we have input port, output port. In this admittance parameter, we are going to express the current I1 and I2 in terms of V1 and V2. I1 and I2 are dependent variable, V1 and V2 are independent variable. So V1, V2, we are expressing I1 and I2. So that I1 and I2 independent, dependent variable, V1 and V2 independent variable. I1 may be considered to be superposition of two components, one caused by V1 and another caused by V2. Right? So the I1 is the superposition of the two components. One is V1 and another one is V2. Now we'll see the two-port network so that we are able to understand clearly. So this is the two-port network available. So two-port network. Input port I1 1 dash. Output port 2 dash plus minus. This is a two-port network. So already we know that this is a dependent variable I1 and I2. Current flowing towards the network, two-port network is I1. In the output side it is I2. So we are going to express this I1 and I2 in terms of V1 and V2. So the generalized equations are available. I1 equal to Y11 V1 plus Y12 into V2. So I1 is expressed in terms of V1 and V2 with impedance admittance parameters. Y11 and Y12 are admittance parameter. We'll see what is the admittance parameter, what is the expression later. So it is I1 is expressed in terms of V1 and V2, also the admittance parameter Y11 and Y12. Similarly, I2 equal to Y21 V1 plus Y22 V2. I2 also expressed in terms of V1 and V2 with parameters, admittance parameter Y21 and Y22. So these two equations are generalized equation. We will see this admittance parameter expression later. From this equation you can frame the matrix. This is a current matrix, admittance parameter matrix, voltage matrix. I1, I2, voltage matrix V1, V2, Y11, Y12, Y21, Y22. So what is this? Y11, Y12, Y21, Y22 are the network function and also called a admittance parameter. So admittance parameter, we need to find the admittance parameter. The name itself is short circuit admittance parameter. We are going to short circuit the output port as well as input port. By short circuiting output port we can find the two parameters. By short circuiting the input port we can find another two parameters. So that it is called a short circuit admittance parameter. Earlier one is that parameter is a open circuit. By keeping open circuit we can find, it's called a open circuit impedance parameter. This one admittance parameter. Right. The individual Y parameter for a given network can be defined by setting each port voltage to be 0. That is short circuit. We are going to short circuit so that the voltage is 0. Now we will find the parameters, admittance parameters one by one. The first one, let V2 be the 0 by short circuiting the port 2 dash. First we are short circuiting the output port 2 dash. The name itself short circuit admittance parameter. So we are going to short circuit the output port 2 dash. That means V2 is 0. Now we'll refer the equation. If V2 is 0, what happened? Refer these two equations. I1, I2. This V2 is 0. So this term is 0. So only we have I1 equal to Y11 V1. So So that y11 is nothing but I1 by V1, right? Similarly, this term is 0. So I2 equal to y21 into V1. So y21 is nothing but I2 divided by V1. Okay. So y11, y21 we are calculating by making voltage is 0, that is output port 2 dash is short circuited. So that we are able to find y11 and y21. Now we'll see in detail. So this y11 is I1 by V1. From the equation we calculated by making V2 equal to 0. What is y11? Y11 is the driving point admittance at the port 11 dash, with port 22 dash is short circuited. It is also called the short circuit input admittance. We know that V1 by I1 is impedance, so that I1 by V1 is admittance. Input side short circuited, output is short circuited, so that it is a admittance input side with output side is short circuited, right? So y11 is a short circuit input admittance. From the expression we are clearly able to identify I1 by V1 admittance input side by making output side is short circuited. Similarly, y21 equal to I2 by V1 by making V2 equal to 0 in equation 2. What is y21? Y21 is the transfer admittance at the port 11 dash with port 22 dash is short circuited. It is also called short circuit forward transfer admittance, right? So transfer, see this, in this we have I1 V1, both are input side, so that input admittance. Here I2 and V1, output current and input voltage is there, so that is called a transfer admittance. Forward side V1 to I2, so that forward admittance short circuited, right? So it is a admittance because of input and output both the parameters available, so that transfer admittance coming under forward. Similarly, reverse is there, and short circuit forward transfer admittance, right? Now we calculated y11 and y21 by making V2 equal to 0. This expression is calculated from equation 1 and 2. The same thing we can go for by making V1 equal to 0. In equation 1, V1 equal in input port is short circuited, so that V1 equal to 0. So we are able to find the remaining two parameters. So now V1 be 0 by short circuiting the port 11 dash. Earlier we short circuited the output port 22 dash. V2 is 0. Now V1 is 0 by short circuiting the port 11 dash. So we can substitute V1 equal to 0 in equation 1 and 2, so that we are able to find the remaining two parameters. Now we'll see the equation 1 and 2. So this equation 1 and 2 is there. Now V1 is 0. So this term is 0. So that I1 equal to Y12 into V2. So that Y12 is nothing but I1 divided by V2. Similarly, in the second equation V1 is 0. So this term is 0. I2 equal to Y22 into V2. So Y22 is nothing but I2 divided by V2. Right? So we are able to find the expression for y12 and y22 by making v1 equal to 0. Now we'll see the detail. This is parameter, we'll see in detail. Right. So that y12, just now we calculated I1 by V2 by making V1 equal to 0. See this. This is also admittance parameter, current by voltage. But current is input port, voltage is output port, I1 V2. So y12 is the transfer admittance at port 22 dash with the port 11 dash short circuited. So it is a admittance because of input and output available, so it's called a transfer. Also a reverse transfer. Earlier forward transfer we already calculated. So short circuit at the input side, reverse transfer admittance because of current in input port and voltage in output port. So that called a reverse admittance. The another parameter y22, I2 by V2. Y22 is the short circuit driving point admittance at the port 22 dash by making 1 dash is short circuited. So both are output port, current and voltage. So that is called the output admittance. Similarly, we have I1 by V1, input admittance. This is output admittance, short circuit output admittance. So we have short circuit input admittance, short circuit output admittance, short circuit forward transfer admittance and reverse transfer admittance. These four parameters are available. So by using these four parameters, we can able to draw the equivalent circuit. The equivalent circuit of the network governed by the equation 1 and 2 is given below. So this is the equivalent circuit. By having I1, I2 current in the input and output port, V1 and V2 voltage at input and output port. Also the admittance parameters Y11, Y12, Y21, Y22. So this is input port 1 dash, voltage is V1, current is I1. This is the output port 2 dash, voltage is V2, current is I2. Now we see how these admittance parameters are placed. So this is called Y11. What is Y1? Short circuit input admittance. So that this is the input side, is short circuit. This output side is short circuited. So it is a short circuit input admittance. Similarly Y22, short circuit output admittance. Input side is short circuited and output admittance. Then another two transfer admittance are available. Y12 into V2. Y12 is nothing but short circuit forward, short circuit reverse transfer admittance. Similarly Y21 V1 is the short circuit forward transfer admittance, right? So this is the input admittance, output admittance. These two are transfer admittance. Y12 is the reverse transfer admittance, Y21 is the forward transfer admittance. So that we are able to complete the equivalent circuit. Now we'll see the further detail. If the network under steady state is reciprocal or bilateral, we'll see what is meant by reciprocal or bilateral. I1 by V2, V1 equal to 0, I2 by V1, V2 equal to 0. If both are equal, then it is called a reciprocal or bilateral. That is forward transfer admittance, reverse transfer admittance. If both are equal means that is called a reciprocal or bilateral network. Under that, this is the condition. So it is observed that all the parameters have the dimension of admittance which are obtained by short circuiting either the output or the input port, from which the parameters also derived. Their name short circuit admittance parameter, right? So all the four parameters what we got is admittance. That is a given here, admittance only, right? Y11, Y22 all are admittance. What we are doing? Short circuiting either output port or input port, so that it is called a short circuit admittance parameters. So in this video, 2-port network, under that short circuit admittance parameters, how we are going to obtain from the basic generalized equation. We found the 4 admittance parameters Y11, Y22, Y12, Y21. Then we framed the equivalent circuit also. Also we discussed the reciprocal and bilateral condition. What is the bilateral and reciprocal condition? Y12 equal to Y21. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.